Hi, my name is Johnny Foisey. I'm from Group R, and my question today was, in a small rural community, records revealed that only 10% of high school graduates attend college or university. The 2018 class consisted of 12 graduates. So my first question was, how is this a binomial distribution? So it's a binomial distribution because it falls under the four characteristics. The first characteristic is there's a fixed number of events, so the fixed number of events is 12. The second one is each trial has two outcomes, and that's either a success or a failure. The third one is each outcome of events are independent, so one outcome won't affect the next event's outcome. And the last one is the probability of success for each one remains the same. So, if you look over here, this is the formula we're going to be using today. The second question I have for you guys today was, what's the probability of exactly one student attending post-secondary? So, question 2. 12, C, and 1. This is the number of events that are possible, and this is the one that we're looking for, of exactly 1. We multiply that with the probability, and that is 10%. And the number is x, so that is also 1. Then we take 1 minus the success rate, and then the success of the number of failures. So, to break down this formula, we have 12 trials, 1 student exactly. We have a percentage of success of 10% with 1 student being successful. And then this, 1 minus 10% is 90%, which is the failure rate. 11 students will fail in this trial. So, when we break this down, this equals 12, so 12 times 0.10 times 0.3133811. So when you multiply those together, that gives you 0.3766 students. So the probability of exactly 1 student is 37.6%. So, question 3 is, what's the probability that it's less than 4 people? So when we're doing that, we already know that we did it for exactly 1, so we're going to have to do it for 0, 2, and 3. So, 0, follow the same formula, so it's 12, 0, times the same success rate of 0.10, 0 students, times 1 minus 0.10, and that would be 12. The answer for this is 0.28243. So the percentage of 0 students attending is 28% roughly. We already have the percentage of 1, so we don't have to do that formula again. So then the percentage of 2 students, we follow the same formula. So it's 12C2 this time. Probability is 10% still, because it can't change. Now it's 2. We multiply that. We get 1 minus the success rate, and our number is 10. When we multiply that across, that gives us 0.23013. So the percentage of exactly 2 students would be roughly 23%. Finally, the percentage of 3 students attending, we're going to follow the same formula we've been following for the last couple of trials. So it's going to stay for 12, C, now it's 3. The probability is still 10%. This time we're going to have 3 successes, 1 minus the success rate, and this time we're going to have 9 failures. So when we multiply that across, this time, smaller percentage, 0.0852. So now that we have all of our probabilities laid out, the probability that it'll be less than 4 equals the probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3. So the probability of 0 is 0.28243 plus 0.3766 plus 0.23013 plus 0.0852. So that equals 0.97436, or in other terms, 97.43%. So the probability of exactly less than 3 students would be 97% chance. That's it.